started playing with your Raspberry Pi yet?
A little bit. I was able to get the S code on there.
Oh, I don't know what that is.
It's a, I don't know what it's called. It allows me to run the programs without having to go into the command prompt.
Oh, okay. I only did 3 Raspberry Pis. I did Home Assist that I told you about for my security system.
Yeah.
I did RetroPie to do video game stuff. And I did one that had Pi-hole. Do you know what that is?
No.
You hook it up to your internet
and
it tries to cut all the ads out before it gets to you, but it slowed my internet down too much, so I didn't keep using it. I don't know if I didn't set it up right or what, because other people don't seem to have an issue, but hey.
What kind of internet provider do you want?
I have Ozarks Go.
Oh yeah, I have the same one.
That's much better.
Good morning, FHS. Today is Wednesday, April 24th, 2024. Would you please join me in a minute of silence? please stand if you are able and join me in the pledge? I pledge allegiance to the flag of the States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, we've got a couple things to clean up today, but we should probably start off with a reminder about our test next class. I said on Monday that, just in case you weren't aware, this is not an A week, this is a B week. Has something to do with when they switched that eclipse day. I don't know, it messed up our Fridays a little bit. So I won't see you guys again until next Monday, but next Monday is going to be your little mini unit test over linear stuff, solving quadratics, graphing quadratics, reading, and graphing piecewise functions. So we did most of the test review last class. Well, actually, before I say that, make sure that since our test is next class, that you have all of your work completed and turned in so that you can get full points for those things. I've not asked for any things from this unit until today. So down there on number 5 under the agenda, I've got 4 different things I'll ask you to turn in. But you probably don't have 2 of those finished right now, so you should probably wait on that. But as promised, I've got a worksheet to give you a little bit more practice on graphing piecewise functions. I think it has 10 or 11 questions on it. That just tends to be one of the things students still feel a little less comfortable with, so I'm trying to provide you that practice. So in just a minute, I'm going to do one of those as an example. I'm going to try to pick out one of the harder ones to show you how I would approach it without a calculator so that you will try the same thing. You need to check your answers when you finish all of them, of course, with the website. And the website does have another worksheet with solutions if you feel like you need to practice even more. Bless you, but that's completely optional. And then last class, I did not give you time. I did not give everybody time to finish the last page of the test review, and I did not give you a chance to ask questions from the last page of the test review. So I need to make sure I offer you that today, since this is the last time I see you before the test next Monday. Okay, so I just was going to pick one basically at random here, not one of the easier looking ones, but something that looks like it would be a little bit harder without a calculator. So again, I'm just doing one kind of as a quick reteach about what piecewise functions are, even though I hope that you are feeling very comfortable with those at this point. Let's see if I can get this over. But I also wanted to pick out one that I thought might feel uncomfortable without a calculator, because some of these are a little bit more familiar than others. Like, I hope you know what this looks like. It's the square root of x flipped over the y-axis. You should definitely know what this looks like. Absolute value function shifted right to, since we've reviewed that recently. But you may not know what this is. And on our test, we will let you have a calculator to check your answers, but you can't use the calculator to get any answers. So your work will have to match your answer. So you can't just totally rely on your calculator. So what I would do on these questions, if there's one of them that you don't know what it looks like, think back all the way back to one of the very first algebra things you ever did before you did much of any graphing, or before you did any graphing perhaps. Just try plugging in x values that look like this would simplify nicely, because this is y equals this. So if I plug in 0 for x, I would get 0, and then that gives you a point of your graph. You could plug in 1, absolute value of 1 over 2 would be a half. And there's another point. You could plug in 2, positive 2 over positive 2 would be 1. Plus, maybe you should go a little bit to the negative side. So absolute value of negative 1 over 2 would also be a half. Plug in negative 2, you get positive 1. Basically, I'm just plugging in any x value that I know, and you can plug in as many x values as you need to until you feel like you have a grasp of what this graph looks like. But this is going to look like square root of x, but this 1/2 is doing a vertical shrink, so it's kind of squishing it. So that's what I have to do when I don't know what a graph looks like. Just literally plug in a couple x values, solve for y, plot the points, and then at some point I feel comfortable enough saying this is what I think it's going to look like. Now, we might as well just go ahead and do the whole piecewise function together, but of course we really only care about the part where x is less than or equal to -4. So equal to means you include it, less than means the stuff to the left and not the stuff to the right. So in fact, when I was making my table, it may have been smart to pay attention to this and really only plug in values less than -4, like -6. -6 would be 3, and that looks good with my graph. Okay, same thing. This one, again, I kind of hope you know what this one looks like. Square root of x is a really common parent function, and that's just the transformation we've talked about a few times. If you put an x or a negative directly on the x, that doesn't flip it over the x-axis, it flips it over the y-axis. So I know what that part's going to look like in general. Bless you. But again, it really doesn't take but a minute to try to like plug in a value like 1, realize that you're taking the square root of -1, which is imaginary, which does exist, but it's not going to show up on a graph. It's not going to show up on an XY graph. So then maybe I realize I need to go to the left a little bit. Square root of 0 is 0. Square root of 1 would be 1. Plug in -2 doesn't come out to a whole number, so I'm not going to do that. Plugging in -3 doesn't come out to a nice whole number, so that's not real helpful for me. But I could plug in -4, which would end up being the square root of +4, or 2. Okay, and for me, I want to say this is probably enough. So I know that it looks like this. Plugging in positive x values, we're going to give imaginary solutions which don't show up on the graph. But before I'm finished with this second piece, I should be careful to include only greater than -4 but less than 2. So greater than -4 would be an open circle, but I'm already hitting that point anyway from the first line, so that doesn't really matter. And then up to 2. But since he doesn't exist here, that part of the graph shouldn't exist, so just that from the middle piece. Okay, and then to just really kind of focus on this point one more time, I really hope you know what the square root of x looks like. The -2 just shifts it right to. That's by far the quickest way to do it. I'm just saying when you get a function, you don't know what its graph looks like, you can plug in values, solve for y, and you just keep doing it until you feel comfortable that you know what the graph looks like. And then for the piecewise function, make sure you only keep the part that it says, where x is equal to 2, close circle, or greater than 2 to the right. So that's what number 7 should look like. So again, even if you don't know what one of those looks like, just a couple points and about 30 seconds should be enough to get you a good idea of what it looks like. Okay, so you feel free to copy that one down as notes. That's one of those that you need to do, so that's fine because you still got a handful of others to practice. So I'm going to give you a chunk of time here to try the rest of these graphing piecewise functions 115, and I will obviously go over any of them you need me to go over, but the answers are on the website, so please check before you think you're finished with that one. And for those of you that work quicker, as you finish that, go ahead and move yourself along to the last page of the test review. If you finish that last class, that's great. Just hang on tight until I ask for questions on that. If you didn't finish the last page of that, then please finish it. Identify which questions you want to ask, and I will give you a chance to ask about that stuff today too. So, And then hopefully you have a chunk of time to look over your stuff in class and review in class, so that you don't have to study quite as much. Okay, so I will ask for the first set of questions about 15-20 minutes from now. So if you get stuck on one, just go ahead and keep on moving along, please. It's a touch early, but figure you might have found one or two by now that you're struggling with, or you just think are a little bit harder. You want to make sure you're doing them the most efficient way. So, is there any of them? Yeah, what you got?
4.
Number 4. All right, well, one nice thing about number 4 is at least it only has 2 pieces. So the first piece, y equals -6. Since it's y equals a number, I know that's going to be a horizontal line where all of the y values are always -6. So that's what the top part should look like, but you should only keep this part of it. So where x is less than -2, but it doesn't say equal to. So since it doesn't say equal to, it needs to be an open circle, and less than is the stuff to the left, not the stuff to the right. Okay with that part? Okay. And then this one's a little, I totally understand why you're not 100% sure what this looks like. So if you take my advice from what the start of class was, if I plug in 0, I get 1 to the 4th, but 1 times 1 times 1 times 1 is still going to be 1. I could plug in a -1, and then I would get 0 to the 4th, which would be 0. So when x is -1, y is 0. Maybe plug in -2. -2 plus 1 would be -1, and -1 times itself 4 times would be +1. Now, I'm not going to bother to keep going over here because I know I'm going to erase that anyway because I've already got those x values. So I might go a little bit more to the right though. If I plug in 1 for x, 2 to the 4th would be 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So this one skyrockets off the page. And essentially what's happening, again, without you having to memorize this, x to the 4th versus x squared. X squared is obviously the most common parabola. X to the 4th just rises a little bit quicker, so he's a little bit skinnier. And then the +1 is shifting it left 1, so that's why that looks the way it does. But then double check that you keep where x is equal to -2. So this one needs a closed circle, and greater than -2. So all of the stuff to the right, nothing to the left. If I had anything there, I would need to erase that. Now, I didn't say this with the first one, but I do think this is a mistake if you don't make this part of your thought process the last 5 seconds of each question. When this says g of x, this implies that g is a function. And we know it to be a function, it has to pass the vertical line test. So if your answer doesn't pass the vertical line test, you should know that something's wrong and you need to stick with it and spend more time on it. Mine does pass the vertical line test. All of these hit at most 1 time, and especially, just as important, x equals -2. Hits here and not here. It's not hitting the graph 2 times. That's why we have to keep up with the closed circle versus open circle, so we know what that value is supposed to be. Okay, did you have anything else about 4? Okay, is anybody else going to ask 4 while it's still up? Okay. Actually, there was one thing some of you might be interested in. This is completely optional, but give me a few seconds here to see if I can remember how to do this in my calculator correctly. Just not something I do very much. Okay, I think I can do it now. Okay, so your calculator can actually graph piecewise functions to some degree. There's part of it that I honestly don't remember. But when the inequality is just x is less than a number or x is greater than a number, there is a way to ask your calculator, don't just graph y equals 6, but just graph that part of y equals 6 that we want. So for those of you that like calculator stuff and technology stuff, so again, if you just ask your calculator to graph y equals -6, it thinks you want the whole thing. But if you really just want it to only graph where x is less than -2, you can go over here and you can say divided by, and then in parentheses you can put that inequality where x, and you have to know where the symbols are. Second Math pulls up all the inequality stuff where x is less than -2, and then in parentheses. If you add this little piece to it, the calculator understands you just want it to graph just that part. And now when I hit graph, notice it stops at -2. Now, it doesn't try to do closed circle, open circle. It's not smart enough to do that, but it can do this piece. And if I had to do this piece, x plus 1 to the 4th, just do it as a separate line. X plus 1 to the 4th. So again, if you don't put any restricts on there, it's going to graph the whole thing. But if you wanted to just graph where x is greater than or equal to -2, you just add, I don't know why this is the notation. It's not really a math thing. Divided by, and then in parentheses put that inequality. Where x is, Second Math gives you these options, where x is greater than or equal to -2. And again, this is the way to tell the calculator, don't just graph it, but just graph this part. Don't graph the whole thing. And then you can compare it to what we just did on our piece of paper, and it works fine. The one thing I don't remember, so if y'all can figure it out, please let me know. But one thing I don't remember is that, like, so I can do this where it's x greater than a number or x less than a number, but I don't remember how to do this where it's trapped in between two numbers. I don't know how you type that part in the calculator, so I'll try to think about it, but I remember it's a little bit different. So anyway, just an option. Huh? No, I know where, yeah, the inequalities are under Second Math. I just don't know how to make this trapped between two. I don't think you can just put the whole inequality in there. I don't think it understands that. It might be like if you put in a second operation, like x has got to be less than this, but I don't know, greater than whatever. You can't type it in the way it looks on your paper. So anyway, totally unneeded, but kind of interesting to play around with, and could potentially check some of your work on the test. So, okay, before I give you a little bit more time, do you guys have another one or two that you tried that you would like some help on? Okay. I will do one more 15-20 minute timer for this assignment. And then if you have questions, you'll need to ask me individually so that we can move on as a group to the last page of the test video. So, one more chance. Anything from the graphing piecewise functions that you'd like some help with? Number 3? Is that what you said?
Yeah.
Okay. Give myself some space here. Alright, so number 3 is going to be a little more tedious just because it's got 3 parts instead of 2 parts, but should be the same process. So the first part, actually I hope that you remember what this looks like because we've talked about this fairly recently. 2 to the x is an exponential growth, and then by putting a negative on the parent function, that would flip it over the x-axis. So this is generally what that should look like. But if you forget that, or if you forget that 6 months from now, and you're in a situation where you need to know what it is, just start plugging in some x values. Anything to the 0 power is 1. Now you do have to do order of operations here. You have to do the exponent first, then the multiplying by -1. Not the multiplying by -1 and then the exponent. That's not PEMDAS. That's not order of operations. So 2 to the 0 would be 1 times negative would give us -1. You could try plugging in a 1 and you would get -2. You could plug in a 2 and get -4. Maybe plug in a -1/2, or I'm sorry, -1, which would give you -1/2. And again, there's no limit on how many points you can plug in. It's just however many till you feel comfortable. So for me, this is enough here. But at the end of all of that, I really only want to keep this part of it anyway, where x is less than -4. So open circle and keep the stuff to the left, not the stuff to the right. Okay, do the same thing with this guy. Again, you really should know what the absolute value of x looks like. That's another parent function. The idea of a parent function is we use them often enough that you get a bit of a shortcut if you memorize them. And of course the negative is just going to flip it over the x-axis. So I have a general idea of what this looks like, but once again, just kind of talking about the worst case scenario here. You're not sure if that's correct. You want to double check it. You've got time on your test to double check it. Just start plugging in some values. Now this time I'm going to be a little smarter and I'm going to just pay attention to these. I don't care about anything to the right of 0, so I'm not going to plug in anything bigger than 0. That just, I mean, it's going to give me part of a graph that I'm going to erase anyway. So if I plug in -1, absolute value of -1 would be +1, but then you multiply it by a negative. Plug in a -2, same thing. Absolute value of -2 is +2, but then you multiply it by a negative, it goes back to be -2. So -3 gives me -3. Plugging in -4 gives me -4. And I really only care about the points between -4 and 0 anyway. So just that. It can equal -4, so this one needs to be a closed circle. It can equal 0, so this one needs to be a closed circle also. So again, I really feel like you should know what it's going to look like pretty quickly, but feel free to plug in a few points to get it to be accurate. Okay, and then the last part, so to me this looks like this would be starting off with the parent function x². The negative in the front would flip it over the x-axis, and then in +4 would shift it up 4. So I feel like this graph is going to look something like this. Okay, again, if you don't know that or you're not comfortable with that, just keep doing it the safer way, please. Plug in 0 for x, solve for y, plot the point. Maybe plug in 1 for x, solve for y, plot the point. Do it again. And again, 4 minus 9 would be -5. Maybe one more time. 4 minus 16 is -12. And that's off the graph. So I know it's headed in that direction, and I've got one more mistake on here. This does not say that x can equal 0 on this part, so I need to make sure that it's clear this is an open circle here, not a closed circle. But that's this part of this function, this part of this function, and this part of this function. So that's what they were aiming for. So again, even if you don't know what those look like, even if you don't know any parent functions or transformation rules, you can still plug in enough points to figure out what it looks like. And honestly, that's what your calculator does. Your calculator doesn't memorize what functions look like. It literally just plugs in hundreds of points and plots them. So, okay, one or two more from this. Others that you think are harder than the rest?
Go over 8.
Number 8, sure. So for number 8, I'm going to take the same approach. I'm going to just assume I don't know what any of these look like, although you really should know what some of them look like, specifically the first one. Square root of x shifted right 3. But even if I make a table, now, unlike the last question, I'm going to pay attention to this restriction here because I really only want values less than 1. So I'm going to plug in 1, -2, absolute value of -2 is +2. But I'm not going to plug in anything bigger than 1 because I'm not going to keep that part of the graph anyway. So I'm going to just keep plugging in stuff to the left. Then maybe start to throw some of that on the graph. Okay, and this is supposed to be where x is less than 1, not equal to, so this has to be an open circle. I got to make sure that that's clear on my graph. And that's not the best, so I'll do a little bit better. That's an open circle, it's not including that point. Okay, the next one, we talked about on a previous question, x to the 4th. It's just kind of a skinnier version of x squared. The -1 is going to shift it right 1. So I have an idea of what it looks like in my head, but for specific points, might as well just throw them in. Actually, and there's only one point worth even doing. It's just this one. It's only x minus 1 to the 4th when x equals 1. So that's the only point that really makes sense in finding here. When x is 1, y is 0. Now, that says include it equal to, so this needs to be a closed circle. That's why this one needed to be an open circle. It's not going to be a function otherwise. It's not going to pass the vertical line test. All right, and then last part, at least for me, this would be the one I am less knowledgeable about what this is going to look like. So, I really only care about values bigger than 1, so it doesn't make sense to plug in 0 or negative numbers. Might as well just plug in numbers that are going to stick on the graph anyway. So plugging in 1 gives me the square root of 4, which would be 2. Okay, that would, I don't want to plot that because I don't want to mess it up, but I will in a minute. If I plug in 2, that gives me the square root of 8, and without a calculator, I don't know, 2 square roots of 2, I honestly could probably think about it. I think it's about almost 1.5 or something. But it's not a nice whole number, so just don't use that one then. If I did 3, square root of 12 is not perfect. If I did 4, square root of 16 would be 4. So that's a nice whole number, so I'll go ahead and run with that one. And then the next one that would come out to be nice would not be 5 or 6 or 7, 8. Let's see, 9. Square root of 4 times 9 would be the square root of 36, which would be 6. So even though that's off the graph a touch, it still helps me see the shape of my graph. And he's supposed to exist not when x equals 1, so right here, but still an open circle, and to the right of that. So, to the left of 1, it's this red. At x equals 1, it's just this purple dot. And when x is greater than 1, it's all the stuff in black. Is that enough? Okay. Anybody else that was going to ask about 8? Okay, so just make sure that if you're not checking those as you work along, make sure you check those as you finish those. Obviously, I'd still be happy to help you with another question or two, but I will do that individually with you, just to make sure that we're all kind of in the same place-ish. So, unless you worked ahead last class, you probably did not finish the back page of 114, which is your test review. So, I need to give you a little bit of time to finish that up, and then I'll give you a chance to ask for some help on any of that back page. And then if there's anything from the first 3 pages that you should have asked last time that you didn't, or anything that you'd like to ask about 115, you'll be able to do that at the end of class. So, of course, as you guys finish up 115 and 114, make sure that you see you should have all 4 of those assignments done now that I'm asking you to turn in. As always, it's never a good idea to wait. You could lose them or forget them. Just turn them in now. It's not any more work. Just do it now as you have them finished. Okay, so we still have about 40 minutes of class. So I'm going to give you about 20 minutes for this last page to finish up whatever you didn't get to last class, and that will give me 20 minutes to take those questions. if that's you or me. Okay, I've been making sure it's not my computer blowing up. Okay. So we've got almost 20 minutes here, so let me first offer some help on any of the back page of your test review. So that would be the last three parts of number 8. Number 8 was asking you to solve by factoring, so we did 3 of those last time. 8 ABC, but you may not have done D, E, F until today. Then 9, knowing that quadratic formula is the only method to find all zeros, even if they're imaginary. And then ask you to practice that method on 3. And then describing some stuff about quadratic graphs. So, what can I help with on this back page? Anything on the back page that you're concerned about for the test? Okay, if you still change your mind, you still got 16 minutes, so call me over or bring it up here to me. But as far as studying for your test, I would start with 114. The test review is probably the thing that's closest to your test. But if within that you realize graphing piecewise functions is your weakness, you might retry some of the questions on 15. If writing the equation of lines is your weakness, you might go back to those 1.1 worksheets and make yourself repractice a couple of those again. But I do need those 4 assignments turned in before we start the test next class. So 110, 112, 114, 115. So of course you can also turn in a hard copy before we start the test on Monday. But if you've got those finished, you might as well turn them in now. So, all right, just let me know if you'll find anything else I can help with. But next class we'll do the test, and then we will start, again, that's next Monday because it's a B week. Then we'll start the next unit, which I believe is the last big unit before we move on into semester test stuff. So, semester test review and things.